Greetings and welcome. This is the first session where we are going to study about the subject HVAC R. We will study here overview of the subject. So HVAC R this subject is studied in a final year of the mechanical engineering. Its full form is heating, ventilation, air conditioning, and refrigeration. Now, these four names are used in the process. So normally this subject is used for the cooling purpose. Now HVAC is a big domain where the different companies are which are manufacturing the machines which are used for some domestic purpose and for some commercial purpose. So we will have list of the applications. First we will see domestic refrigerator. Domestic refrigerator is used for storing the product, okay, which are perishable in the nature, for example, milk, all the dairy products, vegetables, fruits, means whose life is not more than 2-3 days. So to maintain the food quality or nutrition quality of the product, we need the temperature, low temperature. So such creation of low temperature, that is possible by the process refrigeration. So technical definition of the refrigeration is what? So refrigeration is maintain temperature at closed space or desired space below surrounding temperature. So how this is possible? So there we need some machine. So that machine is used in a domestic refrigerator. So normally in refrigeration there are two systems: vapor compression refrigeration system and vapor absorption refrigeration system. VCRS and VARS. Vapor compression refrigeration system, its applications are domestic refrigerator, water cooler, ice cream container. Means all these applications what we see in a commercial shop or in our household applications for low temperature. VARS, where the absorption refrigeration system, that is used for heavy duty applications, means which capacity is big. Now capacity of refrigeration system is indicated by the letter or unit TR. This is called as ton of refrigeration. Now this ton of refrigeration is a cooling effect developed by the refrigeration system at particular space. What is it? So when 1000 kilogram means 1 ton ice is melted by melting of 1000 kg of ice in a 24-hour time at 0 degrees Celsius. During this, whatever cooling effect is produced, that cooling effect is called as 1 ton of refrigeration. Now conversion of TR, tonnage of refrigeration, to SI unit. SI unit of cooling effect is kilowatt. So 1 TR is equal to 3.517 kilowatt. That is a cooling effect of 3.517 kilowatt. That is a effect equal to 1 TR. So all the applications, domestic applications, means for example this domestic refrigerator, split air conditioner, which we use in a home, office. For example, a room of 10 feet by 10 feet by 10. For that room, the split AC, that is used for cooling of air. Domestic refrigerator we use in a house. That depends again, depending upon the use. Water cooler. These are three mostly used for household purpose. Household. That is why we call it as domestic. And commercial level. Commercial applications. Commercial applications where the tonnage capacity is more than 25 TR, 10, 15 TR, about 25 TR. In that, cooling of theater, where malls, where the central AC system is used. So, mall air conditioning, hospital air conditioning, theater air conditioning. These are coming under the commercial. One more application where the production of ice is done on a large scale. So that is an ice plant. This is also commercial application. To store the food products which are imported or which need to be exported, life of each product is different. Some products are durable for 2 days, for example milk. Some products are durable for 8 days, 10 days, like vegetables, fruits. Some products are durable for 2-3 months. These are packed products. So to store these products, a big building with refrigeration system is used. That is called as cold storage. So all these commercial applications, these are having capacity more than 25 TR. We can say in a city, metro city, theater for 500 people, if theater is used. So in that case, that capacity is about 200 TR plus. Ice plant. A capacity of ice plant is about 100 TR. Cold storage is also like that. In domestic applications, the capacity is up to 10 TR. Our domestic refrigerator, actually the capacity is known in the market by volume, storage volume. We say domestic refrigerator of 190 liter, 220 liter, 250 liter, 300 plus liter. That is the storage volume capacity. And tonnage capacity of the refrigerator, that is up to 0.5 TR to onwards up to 5 TR. Split air conditioner, for the house purpose, home purpose, what we use, that AC we say, that is of about 1.5 TR. In vehicle, car, here also depending upon the car size, normally the air conditioning capacity is of above 1.5 TR to 3.5 or 4 TR. So these all applications are having TR value less than 25, and commercial applications are having value more than 25 TR. Now in this case, in all these are all what? Low temperature applications. Means here low temperature is maintained. that is below the surrounding temperature. And for that, one of the processes used, that is a refrigeration. Now remaining these three letters, these are concerned with this subject. Now in air conditioning means what? Air conditioning means treatment of air. Normally in air conditioning, four parameters are maintained inside the closed space. All these applications are carried in a closed space. So first one is a temperature. Temperature inside the space is maintained. Now in air conditioning, for the human comfort, 22 degrees Celsius to 24 degrees Celsius. This is a suggested temperature by the ASHRAE and ISHRAE. Now this is again another topic for the discussion, but just I am focusing a light. ASHRAE and ISHRAE are the organizations which are guiding to the people who are working in HVAC domain. They are having set up some rules and regulations. So this is an American society for heating, refrigeration, air conditioning engineers. This is an organization which is working at international level, European countries. However, for our India, a same kind of work is done or carried by the organization that is ISHRAE, means Indian Society for Heating, Refrigeration, Air Conditioning Engineers. Now by these guidelines, definition of air conditioning is what? Treatment of air where the parameter of air, first temperature, that is maintained between 22 degrees Celsius to 24 degrees Celsius. Second one is humidity. Now actually here in a humidity again there are three types. Now I am mentioning here relative humidity. It is a moisture content in the air. It is given in a percentage. So here 50% to 55%, that relative humidity level is required for the human comfort. Third is purity of the air. Purity means what? Cleanliness. We need clean air, dust-free air. So here in the system, different kinds of filters are used, which are removing the dust particles from the air, and pure air is entered to the space. Fourth one is the velocity of the air, means motion of the air. Here a standard value which is suggested, that is velocity of the air, should be less than 0.6 meter per second. That much velocity of air should be provided by the different devices what we use from the split AC, or in case of commercial central AC, there is a diffuser at the center of the theater. Here this is suppose a hall. So these are the occupant area where the people are seated. At the center here air is carried out by using ducting. Okay, here duct work is required. From the refrigeration unit, that air is cooled and that air is carried out by using sheet metal work, a rectangular shape ducts, and these ducts are connected to here and here one is a device. This is called as diffuser. There are different types of diffuser. Slot diffuser, one of the, its shape is like this, through which that air is sprayed over the equipment area. So this velocity at which air is reaching to the equipment, that is suggested that should be about 0.6 meter per second. So these four parameters are maintained or controlled by the process that is called as air conditioning. Now in this case only cooling is not required, because we know that on whole globe the temperature is not same. There are some countries which are coming under the cold zone. There are some countries which are coming under the hot zone. In case of hot zone we need cold air, but in case of cold zone we need addition of heat. So in European countries mostly the temperature is below 0 degrees Celsius or low temperature. In that case there we need to heat the room. In that case heat is to be added to the space. We call it as space heating. So for that purpose here the process is carried out, that is heating process. And in a hot zone, for air conditioning we need to cool the air. The process is carried out, that is cooling. Now in detail, cooling and heating, that is not sufficient. We have to control relative humidity. So for that purpose the process is their humidification, addition of moisture to the air, humidification. Deletion of moisture means reduction of moisture from the air, that is called as dehumidification. So in actual case in air conditioning the process is a combination of cooling, heating, humidification and dehumidification. Either two processes of these four, what I said, cooling, heating, humidification and dehumidification. So mostly we take example of India. So in our case we do, when the moisture content is more, then we have to use cooling and dehumidification process. In case of cold countries we have to heat the air, at the same time we have to add the moisture. So in that case heating and humidification, these two processes simultaneously are carried out on the air. There are other combinations also, but that we will see in a later session in a detail. Here just air conditioning means what? Controlling of these four parameters by using the process which are carried on the air. So in this way air conditioning that we have seen. So H heating, V ventilation. Ventilation comes, that is what? Motion of air, circulation, best circulation of air. We need fresh air. So entry of fresh air to the space, that is carried out by the process ventilation. We call it as best circulation also. So HVAC R is a full form: heating, ventilation, air conditioning and refrigeration. Now this subject has different units. The first unit where we will see now about the units. The first unit where we study air refrigeration cycle. Air refrigeration cycle is used in application in aircrafts, aeroplanes. For the aeroplane for the cooling of air refrigeration cycles are used. Second one is a multi-stage VCRS means vapor compression refrigeration system, multi-stage. Third one is aspects of cooling and heating. Different. Here we see the different components and controls. Here we see the different components of the system and controls. For example, actually VCRS, vapor compression refrigeration system, is a system which is consisting of 4 components. Mainly 4 components are there. So just I will give in a brief because the length of video will become more. So that is why just the VCRS means what, that we will see. So here these are the 4 locations. These are the 4 components. Where the cooling effect is required, that space, that is called as evaporator. So at this evaporator, to produce the cooling effect, it is necessary to transfer heat of this space and reject that heat to the surrounding. So transfer of heat from one location to another location is how possible? By using external agent, because here second law of thermodynamics is coming into picture. In second law of thermodynamics, it gives the idea about the direction of the energy. Now actually what is it? Removal of heat. Heat is about one kind of energy. So removal of heat means transfer of energy from one location to other location. That is done by using these 4 components. Now for this we need some input, internal energy. Why? Because we in a heat transfer subject, we know that heat always flow from hot temperature to low temperature or high temperature to low temperature. Hot zone means high temperature zone to low temperature automatically by the different modes, means conduction, it may be convection or radiation. These are the modes of heat transfer. So naturally heat transfer take place from hot zone to hot temperature, high temperature zone to low temperature zone. But here we have to remove heat from the low temperature zone to high temperature zone. This is not possible naturally. So that is why here, as per the second law of thermodynamics, we have to use mechanical system that is called as VCRS, which consisting of these 4 components. So in a brief, just I will give idea. Here these 4 components are connected to each other by using tube, because this whole system is a closed system. These are tubes, small tubes. Now through this tube we need to use some medium to carry the heat, because we know that heat is transferred with the help of some medium. So here in this case, in a VCRS system or VRS system, we use the medium that is called as refrigerant, the substance which is circulated through this system in order to transfer heat from this location to this location, that is called as refrigerant. Now this refrigerant again has theory. That also we will see in a detail in some session. Currently just we know that refrigerant is a medium. Now definitely refrigerant has some good properties. That is what? First, its boiling point should be low. Means that refrigerant should be cold. When the cold refrigerant will be there, then it will absorb the heat of the space, and in return temperature of that space will be dropped down. So this is a evaporator. We call it as also cooling coil. Here is a network of cooling coil. Through this low boiling point temperature. Now how much? For the example, we will take minus 30 degrees Celsius. Minus 30 degrees Celsius temperature, refrigerant is circulated here. Automatically here it absorbs the heat from the surrounding and cooling effect is developed inside the closed space. This heat absorbed we have to reject to the atmosphere. So the device which reject this heat, that is called as condenser. But naturally it is not possible because of this low to high. So we have to use some input. That input energy or external agent that is used here, that is called as compressor. So compressor is dividing the operation into two parts. Low pressure side, high pressure side. On a low pressure side, it sucks the heat, suction side. On delivery side, it increase the pressure and reject the heat. So here in the compressor, temperature and pressure, these two properties of the refrigerant are increased. Meanwhile, compressor increases thermal energy level of the substance refrigerant. This thermal energy level when is increased, this refrigerant is at about more than 60 degrees Celsius temperature and about 15 to 20 bar pressure. Now these values depends on the type of application. These values are varying for the refrigerator, ice plant, central air conditioning. But just for example, I am putting the value. So at this minus 60 degrees Celsius, now it is possible to reject heat to the surrounding, because surrounding is at about, in a summer we say 45 degrees Celsius. So this 60 degrees Celsius to 45 degrees Celsius heat can be rejected. So amount of heat which was absorbed here, which was being absorbed here, that heat is transferred by the compressor. Means this compressor is working like a pump, water pump. Water pump, what does? Water pump lift the water from low altitude and it release to the high altitude. In the same way, compressor pick the heat at a low temperature and reject heat at a high temperature. So that is a main input device. It consumes the electrical energy. That is why it is called as heart of the system, compressor. So here in the condenser, heat is rejected and that refrigerant again we have to use. But that refrigerant is at temperature above atmospheric. We have to bring temperature of that refrigerant at this level for the next cycle for the absorption of heat. So that is why here this is a device. We call it as expansion valve or throttling device. There are different names. So expansion valve, it is also called as capillary tube. In a domestic refrigerator, we see this kind of structure, capillary tube. So this capillary tube, through that refrigerant is passed. The diameter of this tube is very small, means about 0.5 millimeter. Through this small diameter tube, when the refrigerant is passed, there more opposition is offered by the surface or material of this tube, and there drastically pressure drop occurs. And this pressure drop from 15 bar to about 1 plus bar, means above atmospheric. Normally the pressure is maintained at the evaporator to avoid the leakage of air inside the system. That is why here positive pressure is required. So above 1 bar, 1.5 say, from 15 bar to 1.5 bar, that much pressure drop is carried out by using the process that is called as throttling process, and that is carried by using expansion valve. So in this journey, along with the pressure, here pressure drop occurs, also temperature drop occurs. So thus here we get minus 30 degrees Celsius, for example, temperature, and now here the cycle is completed. So this is a working of vapor compression refrigeration system. So in this way, we have seen today in this lecture, HVAC means what? Heating, ventilation, air conditioning, and refrigeration. In a refrigeration, we have seen the mostly mechanical system, that is VCRS. Its four components: compressor, condenser, expansion valve, evaporator, their functions. Then behind it, what is the laws? Second law of thermodynamics, that is physics, heat transfer concept. And accordingly, we have seen how the cooling effect is produced. So here, these four components, likewise there are other components which are required to increase the performance of the system. Again, there are some components which are required to control the working of these components. So that all the components are coming under the controls. So HPLP cutout means high pressure, low pressure cutout. When the system pressure is going above the safe zone, system should be stopped for the safety purpose. Or when the system is falling below the certain pressure, again that system should be stopped. So for that purpose, HPLP cutout, that control is used. Here, to maintain the temperature, or to once the set temperature, system is reached to the set temperature, compressor should off. So for that purpose here, thermostat is a device that comes under the control. For the temperature control, thermostat. Now this is in the VCRS system. In case of air conditioning system, we have to control humidity. In air conditioning, moisture of the air we have to control. So for that purpose, to off or on the system as per the humidity required, there we use the device that is called as humidistat. Then there are some other controls here. The compressor, to drive that compressor, different kinds of prime movers are used. Some electrical motors are there. So their controls of motors are also there. In expansion device also here, to control the temperature at this, here also some devices are used. Here condenser, in this, to control the temperature or to maintain the temperature of condenser under a certain range, here some devices are required. So all these are coming under the controls. So that is the third chapter or third unit. Next to this, the fourth, fifth and sixth, these three are coming on the air conditioning. So in air conditioning, we need to study of air properties. So what is that? Is psychrometry. So psychrometry is a science where study of moisture is done, because on the earth air is present, it contains moisture. So as per the requirement, we have to add the moisture or deletion of moisture, removal of moisture. How much? So for that purpose, we need to study properties of the air, means temperature. There are different kinds of temperature: dry bulb temperature, wet bulb temperature, dew point temperature, humidity, relative humidity, specific humidity. Likewise, all these definitions and some laws. So these are studied under the concept or the science that is called as psychrometry. Fifth one is types of air conditioning systems. There are different systems which are used. Just I will give here a brief idea. As per the season, winter and summer, these are two. Third one is all year, this combination of these two. On the basis of this season, on the basis of processes that we have seen just before some time, that is cooling and humidification, heating, cooling and dehumidification, heating and humidification, likewise. So there are different types of systems, air conditioning system. central air conditioning system that is used for the mall, hospitals, theaters. Sixth one is study of duct and design. Now here duct. Normally in central air conditioning system, suppose this is a building, multi-story building, whole building air conditioning is required. So for this purpose here domestic VCRS system is not enough. So here a big capacity, TR capacity, I mentioned that about 100 plus TR. That component means combination of these all, okay, and heat transfer units. That device is located here at the basement, and that we call it as chiller. A chiller is a device in which at the center VCRS unit, and on the both side there are heat exchangers. Means the air which is required to cool so here the space which is to be cooled, that is away from the chiller. Suppose these are different rooms or locations. So to these locations here water, chilled water is carried out. This water, chilled water means what? The temperature of water is at about 4 degrees Celsius to 7 degrees Celsius. 4 to 7 degrees Celsius. At that level, temperature of water is dropped by using VCRS. And this chilled water is carried out by the pipelines by using centrifugal pumps. And then there is a device, we call it as AHU, air handling unit. AHU consists of here inside and outside. There are two sides, input and output. From one side air is passing in, other side air is coming out. So this air is passed over these coils, chilled water coils. Thus temperature of air is reduced, and such cold air is then conveyed to the space, different rooms, by using the rectangular shaped sheet metal ducts, that is called as duct. So in this chapter we have to decide size of duct, means this A and B, suppose these are two sides. So size of duct is to be decided. So that comes under the design. In the design there are different methods by using that. Size of the duct is finalized. That is called as duct design. So in this way HVAC subject or syllabus contains these 6 units: air refrigeration cycle, multi-stage, then study of components and controls of the HVAC, study of air, that is my psychrometry, types of air conditioning systems, and finally duct and duct design. So here we will stop. This was the overview of the HVAC and R. Thank you.